Hello and welcome. I'm Bill Wake. We're here working on the DECT program. Its goal is to take pictures of index cards and load them into the computer using some vision analysis, and then we'll manipulate them somehow to be determined. This is the same session I just did. I messed up something in the video. It wasn't capturing the screen. So what I'm going to do is just kind of walk through a quick summary of where we are and pick up from there. I've got some. I'm gone the next 2 weeks. I may have a chance to record in the middle of the week at some point, but I won't be on my normal schedule until at least whatever 3 weeks from now is. All right. But let's go over to the IDE. I've already done the work. I'm not going to revert everything and try it from there, but I'll just walk through and show what we've done. So the thing we're trying to do at this point, I'll run it again. Sorry. Okay, so the thing we're trying to do is import a list of cards. Let's let that get started. No thanks. There we go. All right, so we have the list of cards. The matching on the rectangles isn't quite right to the actual cards that get found. In this case, they get shifted. The rectangle should shift up half away, but that's okay. We're just going to import this. Now, this is it's a set of stories for a yacht, which is a Yahtzee TM whoever game. Sort of the original version. And I've got 20 stories here, I think. 16, 3, 5, 10, 15, 16, and then one that got cut improperly. I'd like to import these. It has fewer. It's only got 13, I think. But most of them overlap. Okay. The ones that are here are all on the other list. So let's import these. All right, now in my import, what I'd like is the latest import, all those cards are here. So 3, 5, 7, 9, 10, 11, 12. The 12 it found are here. And then there's some that basically, because these cards should match, there's some that get thrown away. Okay, so this has, I think, 8. Yeah, 8 cards in it. All right. But look at this one, yacht. I mean, that looks an awful lot like that one to me. So I'm surprised it didn't get matched out. All right. But what we've done is the current version of the algorithm is you import the first list. It's fine. You have an empty set to start with. So you got a new set of cards. You import the second one. It's going to run through everything in the second list and look for stuff that's in the first list that matches it and delete that. So it takes its best guess on those 12 cards and deletes them. Okay. Assuming it can find anything that plausibly matches. And the issue is the matching is not super great as far as I can tell. And the matches are not very different, and so sometimes 2 cards match the same one or something like that. So 2 things look like the best match for category 4 of a kind, and 2 different cards got deleted. Okay, so we tried putting in a cutoff, but the stuff is so similar you can't really do that. So we can see some values. Oh, okay. That's a little more interesting then. Thanks, Mannerman. I'll take a look later. Okay. So in here, these, the way to read this, the card goes up to the first right per end. Okay. And, oh, actually, well, it goes up to the ID field. So that's the card. And then this is a list of all the other cards' similarity scores. So 19, 20, 18, 21, 17, 14. All right, the best match is a 14, but the range is only 14 to 23. Okay. And this one, the range is 12, almost 13, up to 19, almost 20. Yeah, they're all kind of in that same range. Everything looks about the same. Okay. And so I was hoping you would just take the minimum and it's like, oh, that's clearly going to be the best. All right. So this was my attempt at a kind of correlation score, or catching all the feature scores for the card, each card versus the existing cards. And so, they don't show much distinction. I thought they'd show, 100 points difference or something. All right. So pulling the minimum, I mean, if you know they match, that's one thing, but some of these cards don't match. So it's not really desirable. I talked to that. Maybe you could do something with standard deviations or something and say like, it's only a good minimum if it's, say, 2 standard deviations away. Okay. And, what is that? Like 90% confidence, 90 to 95%, I guess 95 and 3 is 99, whatever. If you could trust it because it was different enough, that might be interesting. If you're just taking the minimum, it could be one random set versus another random set. There's always a minimum, but it's not always meaningful. Okay. So I don't quite know. Well, the thing I want to do from here, the next step. So we sort of did cards in Yacht 1 versus Yacht 2, two different pictures. The range is limited. All right. So what I said was, one thing is, instead of just deleting the most likely match, let's accumulate the likely matches and then delete that list. Actually, it's delete that set, because 2 cards might choose the same match, even though only one of them is probably right. Okay, so only the 2 overlapping matches will only delete 1 item. Okay, and so the improvement will be, we should see fewer cards deleted out of the list. That we don't have this sort of ordering problem where if your first card matches weakly and deletes something, and then your second card comes through, and now the weak match for the other one would be a strong match for it, and it doesn't get a chance to delete. We'll fix that. Okay. Then I have another one that's a hypothesis or a question. What if we improve the color balance and stuff like that before matching? Also, the cards have these little trims. That was the vision stuff. It just said, oh, I'm looking for rectangles. Here's a rectangle. And the fact that it's a little skewed, it accepts that. Okay. But really, I would like to make it so that the white, these are cards with straight edges. I would like that straight edge to be horizontal. And then I think, whichever one was the better horizontal, the other one can go along. I mean, could be a little skew or something if you didn't, you were taking an angle or something. And so we have something going on, but it's not good enough at this point. And I think at this point it's really research, because there's no definition for me that tells me that, you'll get at least, a good match will be 12 or less, or 14 or less, or something. There's nothing like that. It's like, it seems to vary in some minimalistic way that I just don't know if I can trust. Okay. So, we'll see what's going there. So the research part of this was printing out these core feature similarity scores. And I think next time we'll start with building this list of duplicates, see what difference it makes. Let me do another thing. Improve our next image stuff. At least put them in an array. In an array. And have next brief. Okay. So that's another thing we need to do yet. Alrighty. So I think this is my ultra short summary of what we did today. The bulk of the work was in here. Let's see. So this section is we, instead of just adding the new cards, we take each card, build a comparator for it, and then we run through the existing cards. So we have the new cards versus the existing. Run through the new cards. If there is a best match, then remove it. All right. And that's how we got a set of 12 and a set of 8 or whatever it was, rather than two sets of large sets of cards. Okay, once you've removed the old cards, then we go in and add the new cards. They get added to the front because it's newest to the front based on the way we're sorting. All right, and like I said, I may pop in with a surprise midweek session, in probably not this week, maybe next week. Otherwise, it'll be the third week from now that I'll be working on this again. All right. And again, sorry about the video mix-up, and I hope I catch you another time. Bye-bye.